different OSs, data warehouses in our day. We have embedded databases, engineered systems, Exadata, middleware, and basically almost all business applications, business analytics, databases, enterprise performance management, lead management, marketing, supply chain, talent management. Here's just a figure of what the company invested in research, and like last year was 6.2 billion. Okay, as I said, I'm with Oracle Labs. Our mission statement is identify, explore, and transfer new technologies that have potential to substantially improve Oracle's business. And that's also where the project comes in. To give you a little bit more about the background, so if you know databases, basically you have the applications, and on the left side they connect to a database or several databases. And now if you have something time critical, it's practically not fast enough to run all the logic from the application and just send the query or the DDLs or DMLs to the database. So what basically the industry and research has done in the last decades was to basically port business logic into the database. And the reason is, you have the network, there's latency, you have transaction management. If transaction fails, you have to do a rollback. Basically, there's too much communication going through the ether. So basically what you do, you bring the business logic towards the database, and that's what is called a stored procedure. So what the application now does is it bundles a lot of business logic into the stored procedure and just triggers the stored procedure and just gets a result. So that is much faster, and basically the industry is dependent on it. Aside from stored procedure, you have also UDFs called user-defined functions, and those are basically triggered within SQL, so to enrich basically SQL's logic. So you can write your own functions that basically do more than the built-in functions. So for those user-defined functions, you have basically scalar functions that get some input values and produce an output value, but you also have table functions, basically that are used in federated databases as a separate data source. So basically, you could query the web and represent the data as a table towards the database. Or you have user-defined aggregation functions that you could use in window functions or in group by operations. So stored procedures and UDF are basically a target of what I'm speaking about. Now, what are the problems that come with having a stored procedure in UDFs? So basically, you have a vendor-specific language. Oracle uses PL SQL. Microsoft, for example, uses Transact SQL. And those languages, PL SQL is based on ADA, which is pretty old. It's hard to find developers. So that basically costs a company that wants to basically port the business logic towards the database money. And plus it's vendor specific. Then you have a relatively small ecosystem and marketplaces if you compare it, for example, to the JavaScript world where you have NPM. Then comes that it's lagging behind with tool support. I mean, stored procedures you can develop through SQL+, which is like the command line interface. You also have IDE, and you have some debugging functionality, but if you used to any other programming language, you will be disappointed. So it's lagging behind with tool support, and it's hard to manage within version control systems. So what we have done at Oracle Labs is that we have released Oracle Database Multilingual Engine, short for MLE. So it was released as a beta at Open World, which is like Oracle's big conference, about 40,000 people attending each year in San Francisco, which was just recently, beginning of September. So that one is downloadable now, and it's supposed to support multiple languages. Right now it just supports JavaScript, because we have figured that there's probably the market with the most developers. If you look at a recent survey from Stack Overflow, JavaScript was basically the leading language. Then there is TypeScript, which builds upon JavaScript, which basically brings type information towards JavaScript. That was developed by Microsoft, but is basically transpiled to JavaScript and can be executed by our MLE. Then we have Python planned, which is in the works right now, and maybe Go, and that would be up to you, because that would be the project. But to give you a little bit more about the background about our MLE. So right now, we have the Qual VM that was released by Oracle Labs, and right now it supports a JavaScript engine, an R engine. There's also an enterprise R for paying customers. You have Ruby, you have Python, and through another project we can execute basically LLVM bytecode. So those languages basically go into one common framework, which here is called Qual compiler, and this Qual compiler runs on a JVM. So you probably know about the hotspot VM, but for the database we use a substrate VM, which is like a smaller subset of Java that can be run on it. For example, it doesn't support a reflection. And those VMs then are placed into the into MLE, the Oracle database, but Oracle also owns MySQL, so we'll be working on that, and maybe Hadoop and Spark in the future. So when you look of how Java and Python was developed, and basically they started with prototyping the new language. Obviously they started with a parser, and from the parser you got a parse tree that gets translated into a AST, an abstract syntax tree, and then you would have an AST interpreter where each of those AST nodes has an execute function, and you start basically at the root and triggers a top-down recursive execution of the tree. So then you could run your program, but then you would write a real virtual machine that would be written in C or C++, and you would use that AST and basically spend a lot of time of implementing a runtime system, garbage collection, which is tricky. Then your users would complain about performance, so you would define a bytecode format and would write a bytecode interpreter that is not based on those virtual function calls because of your polymorphy compared to the AST interpreter. And then performance is still bad. So basically you write a just-in-time compiler and improve your garbage collector. So with QualVM that has changed. So when you prototype a new language, you still need to write the parser, and you still need to produce the AST and the AST interpreter. But now what Oracle Labs did, it introduced Truffle. And Truffle is basically a language framework that has predefined AST nodes, and it's self-optimizing through profiling and node rewriting. So basically, it's a self-optimizing AST. And then Truffle would run on Qual, and would use its just-in-time compilation functionality. So basically what would be happening, you run your AST interpreter, it starts interpreting your program, and then it would do profiling, and especially for dynamic languages, they have no type information, it would collect type profiles, and at certain nodes it would see, okay, I mean, my number that's coming in is really just an integer and not a double. So let's specialize on an integer, and let's start a partial evaluation. And specifically, the first Futomura projection, which is basically a partial evaluation on your interpreter and on your source code, and you would get a compiled code for that part of your AST, which is obviously faster. Okay, so we have the Quark compiler, which is a dynamic compiler. It does aggressive speculative optimization, but it has guards basically to de-optimize. So once we figure out that the example I gave with the integer is not an integer, it's a double again, we fall back to the interpreter and do more profiling. So it's feedback driven, and it's able to de-optimize, which, for example, LLVM can't do. Then we have the Truffle framework, and basically any language that we implement on top of Truffle is a Truffle language. So Go would be a Truffle language for us. So we have this framework to implement the programming languages, and basically what we as a language implementer need to do is to come up with that AST that we map to our Truffle nodes. And then the self-optimization would come for free because it's already implemented. So the Truffle framework can be seen as a front end to the Quark compiler. And then we have the substrate VM. Remember the slides that I showed where we had substrate VM and the hotspot VM, but the substrate VM is basically the smaller VM. It's basically a garbage collector. Does some other stuff too, but that's its main function. And that will run in the Oracle database and in the same process. So there's no inter-process communication needed. Basically, from our Oracle database is written in C, we trigger a DL open, and that basically opens a shared library where the substrate VM and the Truffle and the language are basically implemented, calls to it, and starts the process. So with substrate VM, as I said, it's mainly doing memory management. You can do stack walking. You have that de-optimization functionality. You can start multiple threads, and you can run in lightweight isolation, which is pretty important, since the Oracle database holds customer sensitive data. Basically, when when you have compiled in, basically you have eliminated branches, right? Like if statements, all those types that you have speculated on, and then you still have to check that basically what you're seeing right now still is still the type, for example. So, but like your compiled code is like compiled for something else. Yes. So you have to de-optimize, which means you fall back to the interpreter. It's yes. But I mean, it's a little bit more complicated than that because obviously they do not always want to fall back, so they have other compiled code might be in parallel, so they can revert to other compiled code, which is like a little bit more general. So Go. So that's what we want to implement on top of Truffle. So Go is an open source programming language created in 2007 by Google employees. It's not dynamically typed, it's statically typed. It has a garbage collection, or it relies on garbage collection. So the original parser and the lexer were built upon Lex and Bison. So that was written in C or C++. And basically what they realized is, since it's an open source language and they wanted to have the community involved, that having the language parser and or lexer and parser written in a different language is not the way to go. So basically they ported that part of the code into Go, and now you can write your Go parser and lexer in Go, and that's actually a pretty nice thing, I guess. I mean, I guess that's what most languages do when they need somehow to bootstrap, right, the language. So they write the parser and compiler in a different language, and once that is done, right, then they can compile their own parser and lexer implementation. So the project what we are proposing is to implement Go as a Truffle language. So the initial parser and lexer from Go, I got some statistics. So the lexer had like 550 lines of code, and the parser had like 1,800, which is like not too big. It's quite it's actually impressively small. But what we would want to do is not to re-implement the parser and lexer, but basically so the output of the parser and the output of the semantic analysis is Go IR, which is like intermediate representation. And we would try to understand those nodes that they are producing, because they're also producing an AST, and would map that to our Truffle AST. And that, if that is done, basically we can also bootstrap Go Truffle by using the Go's parser and lexer implementation, and just compile that and interpret that on Truffle. Yeah, so that would be the project, what we are proposing. If nothing more, if you have any questions.
Questions, anybody? I know the EE's probably close to that. It's all right. How about you CS folks there? Richard?
I would say understanding the Go IR and finding those nodes, but like in the way of translating the parser and as a lexer, I mean, we would see if basically we have unforeseen nodes, right? And we would need to translate them. So basically that's the main challenge. I mean, if the students decide to go with Alexa and parse implementation right away, that's fine too. But like, I mean, I'm not a language guy, I'm a database guy. But like, since Origo bought Sun, we have a lot of language folks, and they told us that this would be the way to go. I mean, I mean, like that's. I mean, like I mean, we always have the database in mind. Yes, yes, Go does it. But the question is, if I mean, like, if the database not already helps. I mean, like, we probably won't need a full-fledged Go implementation on Truffle, because, like, I mean, it does scaling, it does all types of stuff, WebSockets, right? I mean, like that stuff. I mean, you don't want to execute that in a stored procedure. You're not even allowed to. You're not allowed to open a port and like doing that stuff. So, I mean, if the students like advance well, right? I mean, like that can be all discussed, but that's not the initial target.
Anybody else here? Any UCS folks? Well, let's thank our speaker.
Well, thank you for having me.
Don't see any transistors in this one, do you? Okay. Most of our students are EEs, and we had some of the CS people come in particular. Can you make that talk available to us? We could put it up on our website. Okay, so Frank, you can, all right, thanks. So when we get that document, we'll put it up on SDP, and we can write a proposal and approve it, and any of you that want to add. Now, the CS students can also go to SDP, find that project under the fall 2017 session, and then you can show interest in it per our usual procedure. Richard can explain that to you if you're not familiar with it. Well, thank you very much.
Thank you.
All right. So who's next here? Anybody? Yeah, come on up. Okay, hang on. Why don't you keep them busy for a moment? I'll see if I can get my computer to...
Do I have to use this?
Pardon me?
Do I have to use this?
No, you don't, but I would recommend you do, and don't hold it very close. You'll find the people in the back will actually pay attention.
Okay. Well, hello. My name is Luke Chang, and I'm just doing a presentation on a project. You know, it's an aerial wind turbine. Just full disclosure, you know, as it stands right now, it's just me. I don't have funding, and I don't have any like professor helping us out. So just keep that in mind. But I plan on getting funding, and I'm pretty sure we can, because it's not going to be very expensive. So I'm pretty sure it'll be pretty easy to get $200-300, which is really all it's going to require. And also, we'd have to get approval from the University of California, but since this is right down their alley in terms of, you know, green, clean energy production, I'm sure they'd be fine with it. And, you know, we're not going to be destroying anything, and we're literally just going to be floating a big balloon over their campus, so I'm sure they'll be fine. But, so... I mean, you know, we're not going to be breaking anything. It's going to be fine, you know. Worst case scenario, we'll do it somewhere else. You know, not the end of the world. So, like, is it going to be on that computer?
Yeah. It'll be on this one. I have to do this.
data collection.
Okay.
Awesome. All right. Okay, so I'll just start our way. So I already sort of introduced us, so I'll just sort of move on to the next slide. Okay, so airborne wind turbines, I'm not sure if you guys have ever heard of these, but they're a very simple concept. Essentially, as we all know, at higher altitudes, wind is faster, mainly due to, not as much things in the way, and also just you get more influence from the rotation of the Earth and stuff like that. So the higher you go, the better. And that's obviously why we've been building our towers higher and higher. So this is a simple concept, thinking, well, why don't we just go, 1,000 feet, 2,000 feet, 3,000 feet? And so there's three main ideas, essentially, but some people use balloons, some people use aircraft, some people use kites, but the general concept is the same. Go much higher up, get cleaner wind that's not as influenced by obstructions on the ground, and additionally, that also changes your sighting. In other words, you don't have to look for a particular area where the wind speed only 100 feet up the ground is fast enough to be commercially viable. Now you can say, well, it doesn't matter where I am, because if I go high enough, there'll be wind available. So this is sort of what is currently going on in the market. None of these are commercially viable at all. I mean, they're all sort of concepts at the point, but there's a lot of big companies here. This Energikite is this German company. Joby Energy actually is a real company, so this sets them apart. McKinney is sort of considered the only guys who actually have a chance because they're owned by Google. So, that's sort of they've actually got the money. And then that guy over there is the only one that's actually ever been put up and it actually worked. And that's kind of why in this particular project we're going to be focusing on balloons, because as you can see, the other projects, that one uses a kite and these two use aircraft, which the reasoning behind that is the biggest problem, the biggest thing that these guys keep running into is the fact that once you get up to 30,000 feet, you have a 30,000-foot long steel cable, which weighs hundreds of pounds. And just that is, you can't stay aloft. So people, with a balloon, in other words. So people were thinking, okay, we'll use an aircraft and that will have enough lift, but if the wind isn't strong enough, then the thing comes down, and then you got to launch it, and that's expensive. So that's kind of the problems they keep running into. So what this project is mainly focusing on, in other words, we're not going to be competing with, Google. We're going to be trying to make a more smaller balloon-based system at about 500 feet and see if that's a viable system that could actually generate a usable amount of electricity for a cheap price. So we're going small scale while these guys are trying to, go bigger and bigger and bigger. We're going to try to see if we can implement this on a small scale. All right, so obviously application. These are the guys I'm hoping to get money from, the University of California. I don't know if you guys have heard of that plan, by 2025 to be completely carbon neutral. I mean, that's quite an uphill battle for them, but this might be able to help them, and this might be able to interest them. They have a thing known as the UC Carbon Fund, which is a huge amount of money just sort of set aside for this express purpose, to make UCSC, well, the whole UC system really, completely carbon neutral by 2025. So this is right there. More than happy to part with just a small amount of that money to help out with their goal of, generating some clean energy here on campus. Obviously, I know there's been a lot of research with solar panel power, but as far as I know, I haven't heard anything about wind power. And this is the sort of thing where, we're not going to be putting up some giant, huge tower. We're literally just going to build a little floating wind turbine and send it up and tether it to the ground. So it should hopefully remain pretty cheap. All right, so here's the project goal. I mean, essentially, this is all up to subject for change, but this is sort of a rough outline. Stage one would be to build a device, get a weather balloon, hang it underneath it, send it up 500 feet, and just sort of get a read on what the wind speed up there is to see if, how much faster it is at ground, is it commercially viable, how much energy could we theoretically, generate, how big, just get all the data. And then two, we're probably going to run this for maybe 3-4 weeks. It really depends on what kind of data we get, how much of a variance we get, would more data actually give us more viable data, or is it simply just a waste of time if we keep going? And then once we get all that, stage three is to design a theoretical wind device for UCSC tailored for them, depending on the wind conditions we pick up. I would love to build it, but I don't think we're going to be able to get that much money. Maybe we will. But as it stands, the plan right now is just to kind of design it in some 3D design software, have it all laid out, have the cost and the production, and essentially give it to them and say, hey, if you were willing to spend $3,000, you could have this. And that's sort of the end plan is, that's everything leads up to that. So for the first stage, the budget is, as you can see, it's about $300, $400, They usually give things away in increments of $500, and I think that would do it. The big expensive things are the weather balloon, which is about $115, and it's a big giant thing. And then we got steel cable, it's like $40. Now the anemometer, that's something that preferably I would like to build it. Build it ourselves, because then we could use this stage as prototyping. We can actually build an anemometer in the vague guidelines in terms of an aerodynamic, see how it functions in the wind, see if what the maximum wind speed that this thing could operate in, get some prototyping done. But if that turns out, in other words, if we can't build this thing for less than about $100, because $130 will get you probably the best, most high quality, wind speed measurement device you can possibly want. So if we can't do it for less than $130, then it doesn't make any sense to spend all that money, so we can just buy one. But preferably, like I said, I'd like to, build it ourselves. And then finally, there's the helium, which unfortunately is probably going to be the most expensive part of the project, because every time the wind speed goes over a certain threshold, we're going to have to take it down, and then we're going to have to fill it back up, and it's not cheap. And it's about $60 to get a 150 cubic feet to rent a tank to get it refilled, and that might add up. But hopefully we can try to check out the weather reports and try to find a period of time where we can keep this thing up for as long as possible without having to bring it back down. All right, and then we run into another problem, unfortunately, is due to project location. Ideally, obviously, we'd like to set it up here on campus, because that's where the end thing would be. But is anybody here a pilot or familiar with general aviation? Nobody? Okay, I'm not a pilot either. But if you look this stuff up, that big circle that's under us, that's a Class E airspace for Dominican Hospital. I didn't even know, they had a helipad, but they've got a helipad and they've got airspace. So, and if we bust their airspace, in other words, if the tether breaks and that balloon floats into that airspace, we would be in a lot of trouble. So, ideally, when we do build this thing, it will have to have safety features in it, something like a wire running in tandem with the cable. And if the wire breaks, electrical signal's cut, then we have some sort of kill device on the balloon that just sort of punctures it or something, and then the thing just slowly falls to the ground instead of continually going up and taking down an aeromedical helicopter. But so we're limited to about 500 feet. That's really about as high as we could go here on campus. So ideally, if we do that, we go up 500 feet and we realize it's not enough wind, well, then we can go to Mount Lick, because that's also owned by the UCSC property. If we can get approval for UCSC, I'm sure they wouldn't mind that. We get the advantage of being 3,000 feet up. You're in the mountains, so just another 500 feet. There's no obstacles around for miles. You get all that high-speed wind. And even if that's not enough, then we can go higher. And going higher is simply a matter of we'd have to get in contact with the FAA. There's precedent for this stuff. I mean, mainly it's people who do they get weather balloons and they just send them up to 100,000 feet. And so that's totally okay. You just have to get approval from the FAA. You have to fill out all these documents and stuff. So if necessary, we'll do that. But hopefully, ideally, 500 feet on UCSC campus will work. But those are sort of just contingency plans if that doesn't work out. All right, in terms of what we're looking for, essentially this is, I sort of kind of tailor-made this for EE guys, but there is a lot of computer stuff that would be going into this, mainly in the simulation of the device to see how it reacts to the wind, to make sure that it doesn't have any problems with stability. And also additionally, weather is going to be a huge factor. It's the kind of thing that if we don't have a CS guy, someone's literally going to have to check the weather every single day, and sort of that's going to be his job. Ideally, if you could set up something where it would just beam us a little alert, get something on your phone being oh, the wind speed's predicted to be over 45 tomorrow, then we could just, go out there and take it down. That'd be really nice. But, so essentially anybody who's interested or familiar with aeronautics or aircraft or anything to do with streamlining, that would be incredibly helpful. People who know things about things like SolidWorks, 3D design software, that would be very helpful. And obviously also electrical power generation, electrical power transmission, because we're going to have to interface with this thing. Even just the wind speed measurement device, we're going to have to get signals from it. We're going to have to send signals to it through a 500-foot long wire. And that's an enormous amount of resistance, so there's going to be amplification involved. We're going to have to make sure everything meshes up correctly. So that kind of stuff. And also, if you've got anything to do with statistics, that would be incredibly helpful. Or weather, if you know anything about the weather, that'd be great too. So that's kind of what we're looking for. And finally, yep, that's just, if you're interested, please email me. That's my email. And are there any questions? Doesn't seem like it. Okay. Good. Oh. No. That's the kind of thing that you kind of have to, it really depends on what kind of budget we have. You know, if we have like, you know, if they somehow get fallen, you know, if we get like $2,000, $3,000, then we could conceivably actually build one of these things. But anything less than that, it would be a prototype, it would be a demonstration model, which would still be great. But I'm sort of going off the assumption that $500 is the most, I'm pretty confident that I can get $500. Anything over that is sort of a, depends on how good we do our pitches, depends on how interested the, you know, the UCSC system is in this thing. But absolutely, yeah, if we could build even just a scale type prototype that actually generates power, that'd be great. But as the baseline is just a wind measurement device.
Anybody else? Really? Only one question?
Build it by hand. I mean, this is the kind of thing where it's almost like a marketing pitch. You know, I want to get all the data together and actually have a sales plan for UCSC, and whether they buy it or not, that's up to them. You know, but this is essentially just data collection and designing it and saying, you know, here's our product. Do you want it?
Only two questions? I have some, so if there's no more students.
Yes. Oh yeah, there are several companies have run these like wide. In other words, not in terms of a specific location. They have statistical analysis where they say, well, statistically this and that and this, and you know they have big color charted graphs of the entire United States where they say, yes, in this particular area, roughly this, roughly that. In terms of actual data that you could actually use to build an actual wind turbine, that's something you can't get from statistics. You literally have to send up an actual probe and figure out, well, what is the wind up there? Because we really don't know. They're just sort of estimating it, and that's what we got. And you can go off of that. That's certainly helpful, but it's not enough to actually build a wind turbine around that.
Anybody else? So have you done any serious meteorology study?
Meteorology study? No.
NOAA has a series of wonderful websites where they will give you the winds aloft as a function of height all the way up to the 300 millibar. Now, it's all calibrated in terms of pressure. How many of you know the jet stream is about 500 millibar? Anybody know? I didn't think so. The meteorology part of this needs to be studied carefully. And pursuant to your question, I think there's more than statistical evidence available for wind speeds aloft that you can access right now off of NOAA. There is NOAA weather sites. I monitor them to keep track of local weather, and I watch the 500 millibar winds aloft for the jet stream because that greatly affects weather systems down here on the Earth, namely our approaching ultimate low-pressure systems coming down from the Gulf of Alaska. My point is that there are maps that are published in real time every day that give you estimates of winds aloft at a whole series of different heights. And I don't think you've considered those. I think you should, and quit looking at companies who have done statistical measurements. There is real scientific data. The second looked at the angle of a balloon which goes aloft that it's going to make with the plane of the Earth as a function of the force velocity vector from the wind acting on that object. Have
Yeah.
you thought about that?
Yeah.
What
You-
is the angle?
Well, it depends on how fast the wind's moving.
That's a tautology. I'm asking, so if you've looked at it, or have other companies indicated what that angle is? What's the worst angle? The reason I'm asking is because on field day, our amateur radio club, 5 years ago, 6 years ago, one of the ham members wanted to put up an antenna, a wire, that went up, and he had a weather balloon. So he brought a weather balloon and filled it with helium and connected a wire to it. And in his mind, it was going to go straight up. Well, we live in something called the marine layer on the west coast. There are diurnal winds that move in and off the coast daily. It's called the marine flow. And in the evening, the winds were kind of kicking up. And that weather balloon formed about a 20-degree angle with the tether point on the Earth. And I wonder what the angle is going to be with this thing. If you get it up 500 feet, that angle is probably going to be quite small because of the wind. And the force factor acting on that, if you're going to convert wind energy to electric energy, that's going to have a counter force, which I think you need to look carefully at. So those are the two thoughts that I have. So, anybody else?
Yep.
Kevin?
It's mainly the fact that it's very expensive as it stands because it's huge. You know, that balloon was just, it's, larger than this room easily. It's just a massive, giant thing. And just the fact that it's so big is the main problem. You know, it's expensive to truck it out there. It's expensive to get that much helium to fill it up, and then they send it up, and then if the wind kicks up too much, then they got to take it down, refill it, and all that process just makes it too expensive. That's really the thing that they keep running into. So that's why, the idea here is to go smaller, to go a lot smaller and kind of, go for micro wind almost. Oh, yeah? I haven't seen anything. I mean, it's entirely possible they have. But in terms of what the data they're putting out, in terms of the publications, it's always bigger, 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 bigger. And they'll just try to overcome the problems, with more engine power, bigger wings, bigger balloons, I've seen nobody trying to go the opposite way. Oh yeah, no, the end product. I mean, like as far as I'm concerned, it would really depend on the data we collect. But I'm seeing something that would fit in your garage. That's about as big as it's going to get.
Where have the experimental turbines been deployed?
Almost exclusively in the Mojave, at least for the American companies. I honestly don't know about the European companies.
Okay, in a desert?
Yeah,
Is there a reason for that?
airspace. There's nothing out there.
What about safety?
Yeah, that's also a very valid point. It's probably nothing to hit when you fall.
So I think if you put it up and handle all the safety eventualities, that might be important. Besides just airspace, I mean, airspace is a consideration. This might work in the desert or it might work over water, but I am a little skeptical you'll be able to get it from the UCS. I just think, you really need to pay attention to that. What do you guys think? Any thought on that? Yeah.
I was thinking of just having a simple microcontroller that would open the valve and do a lot of calculations. See, like, well, if we open the valve for this X amount of time, release X amount of helium, that would bring the buoyancy down to just a little bit below neutral. So hopefully it would just slowly come down, and we could probably even pull it in a little to help it out. And that would also be the same thing with the kill switch. It's if the cable breaks the wire breaks, no more electrical signal, then the thing just opens it up and the thing just sort of, you know, would come down. Hopefully slowly. If we do our calculations right, it should be safe.
There's a lot of wind right on the coast, so I predict there will be a lot of wind over UCSC. It might be legally viable to deploy this slightly off the coast to seaward because of safety issues. So
Oh,
I
yeah.
just raised those points. So anyone who's interested in this, when you brainstorm this, don't leave out the safety issues and to review those other studies that you mentioned. They've been doing it over the Mojave because of airspace, but there's probably also safety. There's implicit in that too. So, any other questions? All right, well, thank our speaker.
Hey, can I get my flash drive back?
Pardon me?
My flash drive?
Would you like your, oh, did you have more?
No, no, this is it.
I was gonna steal your, All right, do we have another speaker? I think we do. Yes. Herbivore, right? Yeah. Do you have a flash stick or anything, or just want to come up? If you have it, probably emailed it and I don't have it. Tila might have it. All right, I appreciate that, because then we can just stick that in our computer. Any takers for Oracle? Oh, come on. We must have some enterprising EEs here that want to work on garbage collection and optimize an AST interpreter. It is a pretty interesting project. It's pretty CS-centric. That's definitely true. How innovative is that, do you think? I'm wasting time here while I'm getting a flash stick. How innovative do you think it is? No opinion. Okay. So where on here is this? This one? Okay, so just go ahead and double click it. Is that a PDF?
Yeah.
All right, I'll put it over. There you go.
And kind of like. Okay. All right. Hi. My name's Theron. If y'all don't know me, so I've currently been assigned to Herbivore. Emailed them and they picked me up. Still pending. Given I construct a team, but that's why I'm here talking to y'all right now. So Herbivore is tasked with designing the U-Bloom, which is an aeroponics platform for mobile urban residents and food insecure families. So basically people that may be lacking in proper nutrition in regards to vegetables and fruits. And yeah, moving forward. So what is aeroponics? So aeroponics is an alternative to growing crops that primarily focuses on enabling the plant roots access to oxygen and maximizing the plant's access to light sources and nutrients. So the main thing surrounding aeroponics is that the roots are not surrounded by a normal aggregate, meaning it's not surrounded by soil, which means that the density of the nutrients within the aeroponics aggregate can be lessened, and more of the nutrients can be accessed by the roots of the plant. Also, within an aeroponic system, you have normally a controllable light source, that can be intensified so that the light intake during photosynthesis can be increased. And then lastly, you have a misting system that applies very controlled size droplets of water nutrient combination to the exposed roots of the plant, which increases the nutrient intake of the plant and helps it grow better. So, Herbivore is creating the U-bloom in an attempt to kind of disrupt an emerging field. So aeroponics has been in development primarily by NASA for the past, I want to say, well, they've been doing experiments with plants in space since like the 60s, but within the last, I believe, 20 years, they've really made a push towards trying to develop aeroponic, hydroponic systems that can be used in traveling to Mars and can be used as sustainable systems in space, as well as used as ways to study plant growth under controlled environments. And there's also many companies currently that are trying to reach out to urban environments, basically places that don't have a lot of space, in creating different aeroponic systems. But the issue is that the aeroponic systems that they're trying to create are really expensive. So Herbivore is trying to create the U-bloom to undermine a lot of the expenses that are associated with aeroponic devices currently and reach out to really low and medium income families and individuals. So the U-bloom system is in the prototype stage, as y'all found out a little bit earlier, and it's comprised of a nutrient/water reservoir tank, which is going to be the upper right image. You can see it's called the sump tank. That controls That controls a concentrated and balanced nutrient concentration with water. You see the concentrate box, box that actually contains concentrated nutrients that are pumped into the reservoir tank given the electrical conductivity of the tank is below a certain threshold. Then you see the electronics box, which is housed in a semi-waterproof container, part of the design elements we need to fix. So what happens is when the electrical conductivity of the sump tank decreases, the concentrate, or the electronics box will, rather the control system of the entire U-bloom system will adjust the concentration of nutrients within the sump tank and then pump the sump tank contents through the fluidic system into the misting system, which is the bottom picture right here. And that misting system will disperse to the roots. And as you can see, you see these green boxes on this long tower. This is really a shell of the U-bloom system, but the green boxes, there's little holes at the top, and those holes are where the plants are actually placed. The pumping system that you see here is within that box, and it has levels to it that it has levels to it, and they're looking on both sides. So basically, it's not necessarily modular at this point, but it's condensed and it's packaged so that there can be growth or a large amount of growth in a small area. Oh, yeah, cool, thanks. Okay. So for May 2018, Herbivore wants us to deliver on 2 working U-bloom systems. And I'm really excited because they're going to be deployed at UCSC. And I'm excited about that because UCSC is not known for funding resources that are easily, or rather not known for funding the available resources that we have on campus, such as the food pantry and things like that help students that are in need. I personally have a lot of friends that have been hospitalized due to malnutrition. So I believe that given that we have U-bloom systems that actually work, UCSC might be more inclined to invest in some of the systems and things that will help students on campus. And more Herbivore deliverables are that Herbivore wants us to rework, improve, and test the web test mobile app that they have developed currently. So the Herbivore system as a whole has a series of sensors that will determine temperature, it will determine electrical conductivity, it'll determine light intensity, and it has a feedback controller that adjusts all of these variables, yeah, based off of set standards. So they want us to basically adjust that web mobile app, in a sense, maybe gamify it, and make it easier to teach people that use the system how to grow plants. They also want us to optimize the overall UBloom system. This means the sensors. This means the power budget of the UBloom system, the mechanical design of the UBloom system. I'm going to go a little bit deeper into that. And then they also, and this is one of the most important, they want us to decrease the system cost and the energy consumption, which inherently means the system cost. Let's move forward. So in regards to the web app, I'm really excited that some of the CS people are still here. So the web app, as you can see, gives outputs of the sensors and gives the current status. So it has a state machine that constantly updates the status of each sensor, or a variable for each sensor, and that's displayed, or rather sent via Bluetooth to whatever device you're using, which is right now Apple products, because the web app was developed in Swift. What we want to do is improve the UI design so that it can teach, so that it can include a kind of game system that can help teach people that are using the system how to use it better and how to grow plants better. And I'm talking to a few of my game design friends to try to get some help on that. So they also want us to test the sensor functionality with the mobile app. So basically, is the data that's being sent accurate, and are the sensors reading accurate data on the UBloom? And then they want us to evaluate the software glitches and bugs, and that's going to be in Swift. And then lastly, this is something that I kind of want to do. I want to port it to Android. I don't use Apple, and a lot of people don't use Apple. So that's going to be in Java mostly, because most Android apps are developed in Java, but yeah, CS people. All right, next up. So in regards to mechanical optimizations, what we're gonna need to do is improve the electronics housing of the circuits that we have in the PCBs, because the environment is damp. We're using mist, and we measure a lot of the moisture in the environment surrounding the roots, so we don't want to degrade our circuits, basically. We need to isolate the fluidic system, and we need to use injection molded plastic so that the design can become more manufacturing friendly. Injection molding is just a little bit easier to manufacture than laser cut plastic is at this point. And then lastly, we need to do a potential redesign of the misting and pumping and fluidics design, because like I said earlier, the size of the droplets really matters. So if it's too small, what will end up happening is the plants will develop a lot of, they're called root hairs, instead of lateral roots, which are necessary for the aeroponic system to actually function properly and plants to grow. And then if they're too large, if the droplets are too large, then oxygen won't be able to be absorbed by the roots, because the droplets will be big and will cover more surface area. And oxygen is necessary in the respiratory process of the plants. Okay, now in regard to the sensor optimizations, we're gonna need to implement, or rather redesign a light sensor. So we're gonna need to design it so that it's a photosynthetically active radiation sensor, which basically means that it's going to be able to only operate in, or it's going to filter out all light except for light that's used during photosynthesis. And that's important because we need to be able to measure the efficiency of the actual LEDs, because those are the biggest energy drain for the device as a whole. And if we can either design using more efficient LEDs, or design design so that we can increase the energy consumption, then the overall energy consumption is going to decrease and the price is going to decrease. We're going to need to redesign around the moisture sensor, which controls whether or not the misting is going to turn off or turn on. So if the moisture, basically, if the amount of moisture in and around the roots of the plant is high enough, the mister is going to turn off, and it's going to indicate that the necessary amount of nutrients and water has been applied to the roots. But the problem currently is that the moisture surrounding the roots and the aggregate that is used in the aeroponic system is too variable. So the sensor readings are really inaccurate. So we're going to need to do some brainstorming and design around how we're going to implement that. Then what we're going to need to do is finish and possibly definitely redesign the electrical conductivity meter that they currently made. They started a design for the electrical conductivity meter, but ended up using a commercial conductivity meter. Run out of time? Okay. So yeah, we're going to need to do that. And then we're going to need to do a lot of research in regards to the specific sensors that are available and can be implemented. So like I said earlier, there's a control system. So for the control system, we're going to have a lot of data collection in order to gain an understanding of optimal conditions for the sensors, as well as baselines for the sensors, and then any additions that are made to the sensors, to the sensor system, is going to result in a change in the state machine of the control system. So there's a lot of work there. Now, for the budget, we currently have $7,000 to $8,000 from the UCSC Carbon Fund and the Measure 43 grant collective. I'm going to be applying to the Idea Hub competition, as well as the Big Ideas competition, which might give us a little bit more funding and resources, as well as lab spaces, which is something that we're looking for right now. And here's a timeline. So for the fall, Herbivore wants a feasibility study of the U-Bloom and the mobile app. And then in the winter, they want prototyping and optimization to take place. And lastly, in the spring, we need to have complete optimization of the U-Bloom system and the mobile app completed. And they want the functional units out and being used in UCSC. During the fall, we're also going to be designing experiments so that we can perform our optimizations in the winter. Yeah, if you have any questions, email me or call me. And, yeah, thanks for listening.
So, do you have any quick questions? This sounds pretty interesting. I see some real challenges here. We don't have time to go into them, but I think you covered that quite adequately well. Yeah.
Yep, and that's what that's how the experimentation comes into play. So people that are interested in research, this is going to play a big role, because we have to model these systems appropriately. And we're going to be really touching on leafy greens for like currently, and that's how they modeled the prototype. We'll expand if we have time, but as of right now, that's how we're modeling it. Yeah. So the entire system is going to accommodate a bunch of different types of plants. And that's Herbivore's end goal.
Okay, it's 10:30. I've got to go to a faculty meeting where we'd sit and chew and talk to you for a while.
Yeah.
Thank you very much.